For problem number 5, they give us x is 3t and y is equal to 9t squared. And they tell us that t can be from negative infinity to positive infinity. Now they do that on purpose to kind of trick you. Now this is actually a pair, you guys don't know it, but this is actually, I think it's y equals x squared. It should be a parabola. So now that we're in parametric mode though, let's plug it in and see. So if I come in here on my calculator and I graph that, I'm going to let x equal 3t. And then I'm going to come down here and I'm going to let y equal 9t squared. And if I hit graph, hey, it's a half of a parabola. Now, but it says let t be from negative infinity to positive infinity. So now we're going to, when we did this problem before, it was 0 to 2 pi. So now I'm going to come in here. I can't put in infinity, but I can put in a big number. Let's let t equal negative, oops, not that, negative 1,000. Oops, is that right?
Yeah. Negative 1,000.
Oh, I've got a blip on my screen. It makes it look funny. Oops, hold on, I'm not done. Really annoying. So let's just do like, let's do negative 3 pi to 2 pi and see what we get.
Negative 3 pi to 2 pi?
Well, just for it to fit in the window. So now, what does it look like?
The same for me.
It's the parabola. So we want to know, it says graph the curve, and then what are the initial and terminal points? So the initial point is where the graph starts, or what is the lowest value for t. Now some of these will draw funny patterns, like on our previous problem where it'll draw a funny pattern and the pattern repeats itself. But this is a parabola, so the pattern doesn't repeat itself. So t could literally be what? Yeah, anything. Negative t to positive t. But now it says for part B, so what is our initial and terminal points? You can't really say it, you can't define it. It's like negative infinity to positive infinity, but that's not really a point, is it? Okay? Well, for part A, there's really nothing to write. Huh? Now, can you indicate the direction in which this goes? So we've graphed it on our calculator, so let's do it this way. So this is our function, and one way to think about the initial and the initial and terminal points. So this is what the graph looks like. This is the graph of our parametric equation. Now we know, because we've memorized quadratic equations, that this is the same as y equals x squared, or some variation of it, right? But what is the path? If I start at negative t, where do I end up with? Or what's the path that we travel? So if I hit trace, this will look a little different on the parametric equations. When I go to the left, it's going to change the value of t. So as t increases, what we're going to look for, and it should be coming into the, you should be able to see it in the screen pretty soon here. Well, we're not, you got to look at the x and y values. See, my y value isn't in the screen yet. So if I start at negative infinity for t, as t increases, what's the path of the curve?
I don't know, I can't see my little thing.
Well, just look on my screen. Okay, so let me start over. Here's a low value for t. As t increases, what's the path of the curve?
It gets more positive?
Well, it just flows this way.
We can't see it on the screen. Like when you put your calculator there, I could.
Oh, I'll do it again.
It's okay. I get what you mean.
But that's the flow of the curve. Now, that isn't always the case. Sometimes, depending on the parametric equations, the flow will be this way. we're used to in the Cartesian equations, it's always going left to right, right? We're used to always kind of going left to right. But now we've got these swirly things, and so remember when we saw those other ones drawn by the calculator? It went this way, this way, this way, this way. So we've got to consider, as t increases, what is the path of the curve? So for part B, that's kind of, you can draw it this way. You can illustrate it this way with an arrow showing you the path of the curve.
So when it says what portion of the graph equation is traced by the parametric curve,
So yeah, so
draw an arrow.
you could draw an arrow, but now we want to be a little more formal, and we've got to show that it's y equals x squared. So if we think that's what it is, what is x squared?
A parabola.
A quadratic function.
Yeah, but we're gonna,
Just guess this.
You can literally just
no, I have the
square
answers
x
in the
and it
book.
equals y.
No. If you say x equals 3t, and I square this side, and I square this side, what does it equal?
The y.
X squared equals 3 squared, which is 9, t squared.
So you just look at
So what is y though, right? So y is equal to 9t squared, or y equals x squared. So this is how you, so you know, our textbook, if you look on the front of your textbook, it says AP Calculus numerically, graphically, algebraically, analytically. So we've done all those things. We've looked at it graphically, right? We've done some algebraic manipulations to prove or show, okay? Now, for what values of x? Or I mean, your answer would be for all. So let me read the question again. It says, find the Cartesian equation for the curve that contains the parametric curve. What portion of the graph of the Cartesian equation is traced by the parametric curve? So sometimes, depending on how they define t, you may only have like the positive half of the curve, right? If t was 0 to positive infinity, this would be the curve. That's all we would see. And then our initial point would be 0, 0, and our terminal point,
That's what I put, but
Yeah.
that's wrong.
that's wrong. Because they defined what t should be. Okay? So it takes a little getting used to. So let's